Okay, we're going to talk about division of complex numbers here. Okay, let's start off with an example. First let's discuss something that's a previous topic. If we have 10 divided by root 6, right? Do you remember the term where we have to rationalize the denominator? Because we don't want this negative in the denominator, so we must rationalize it. Well, that's kind of the same idea. Let's go ahead and rationalize this denominator. We multiply square root of 6 times the square root of 6, right? The square root of 6 over the square root of 6. This is how we rationalize this denominator. Is equal to 10 root 6 over the square root of 6 times the square root of 6, which would be the square root of 36, which will be 10 root 6 over the square root of 36 is 6. Okay, so basically the reason that we're doing this is the reason that we multiply by the square root of 6 is so that we can get this radical out of the denominator. Okay, then we can simplify this here. We can 2 goes into 10 about 5 times, and 2 goes into 6 about 3 times. So we have 5 root 6 divided by 3. Okay, because 2 goes in there 5 times, and then 2 goes in there 3 times. Okay. So this will be my answer with a radical not in the denominator. Okay. So now let's see how this will apply to my complex numbers. Okay. Let's start off with a simple example here. Let's say we have 3 plus 7i divided by 8i. Okay. We want to get this I out of the denominator. Okay. We don't want any i's in the denominator. So what we'd actually have to end up doing is this same process here, taking the I outside the denominator. Okay, the way we do that is not by multiplying by this number, but multiplying by its conjugate. If you remember conjugates from my first video around complex numbers, okay, we talk about conjugates being the opposite sign of your complex number, of your imaginary part of your complex number. Okay, so let's go ahead and multiply. Let's multiply 8. This is how we're gonna do this. We're gonna take minus 8i and we're gonna multiply it times 3. Okay, and then we're also gonna multiply minus 8i times 7i. Okay, and this is going to be divided by 8 times 8. 8 times negative 8 be a minus 64 times I times I give me I squared. Okay, so let's go ahead and handle this problem here. Okay, so let's get started. This negative 8i times this 3 will be a minus 24i. And this minus 8 times this 7 will give me a minus 42. I'm sorry, this will give me a minus 56i squared. A minus 56i squared. Okay, divided by negative 64, multiply times I squared. Now remember, I squared is the same thing as negative 1, right? So this will be a minus 24. I'm sorry, yeah. This will be a minus 24. Straighten that up. Minus 24i minus 56 times I squared is negative 1 over 64. Okay? Now, let's scroll this down just a little bit here. Now, what do we have? Well, we have minus 24 plus 50. We have minus 24i. Minus 24i plus 56. Well, minus 24i plus 56 divided by 64. Okay. Well, it looks here that we can't simplify this any further. Let's go up here. Let's take this step up here. It looks like we can't simplify any further here. So we just have, let's see, this 24i plus 56 over 64 will actually simplify to, let's see, this will be a minus 3 plus 7 over 8. This actually be a minus 3i plus 7 over 8. Okay. Now, this is actually the answer here, but if we want to write it in the form of a plus bi form, what we have to do is we take this minus 3i and put it over 8 plus 7 over 8. Okay? And then reverse the placement of these, because remember your imaginary part goes last and your real goes first. So reverse the placement of these, and then we're left with 7 over 8 minus 3 over 8i. And that would be your answer. Okay? Now, let's go ahead. Of course, we're going to do another problem just so that you guys are very fluent with this. I hope you guys understood the analogy I use with these rationalize the denominator here. Okay? So let's go ahead and get another example done. All right. So let's get this problem here. This is a little bit more complicated problem here. We have 5 plus I divided by 2 minus 4i. Okay, that's not straight. Let's write that straight. We have 5 plus I divided by 2 minus 4i. Okay. So, of course, we're going to do the same thing here. We're going to multiply by its complex conjugate. Okay? So, we have 2 minus 4i here, so it's going to be a 2 plus 4i here, and 2 plus 4i. Okay? So, basically, we're going to actually hit the FOIL method here because we'll have this will be equal to 5 plus I multiplied times 2 plus 4i. Right? Divided by 2 minus 4i multiplied times 2 plus 4i. Okay, well, let's see what this gives us. We'll FOIL this. We'll get 5 times 2, which will give us 10. And then this 5 times this 4, that'll give me a plus 20i. And then when I multiply these two together, I get a plus 2i. So I can add those and get a plus 22i. Okay, now I just have to do my last because I did my first times first, my inners and my outers. Now I just got to do my last. So I times 4i. Okay, so 4 times 1, because it's assuming this to be a 1 in front of here. So 4 times 1 will give me 4. I times I gives me I squared. So this is plus 4i squared. Divided by, well, remember what we said when we're dealing with complex conjugates. You know, we're going to end up with a real number, the denominator. So let's go ahead and multiply it. I didn't mean to do that double indication. Let's go ahead and multiply it here. Okay, so we'll have 2 times 2, which will give me 4. Then 2 times this 4i, which will give me a plus 8i. And then these two, negative 4 times I times 2, they give me a minus 8i. And then this, our last term is minus 4i times plus 4i, give me a minus 16i squared. These 8i's cancel, right? Then I'm left with 4 minus 16i squared. 4 minus 16 times negative 1, because remember I squared is equal to negative 1. Then I'm left with what? 4 plus 16, which is equal to 20. Okay? So we're going to go ahead and write 20 in our denominator here. I'm erasing this because we're a little scarce of space here. So 20. Okay? So let's go ahead and move down here. We have 10 plus 22i plus 4 times I squared. I squared is the same thing as negative 1. So 10 plus 22i minus 4, because 4 times negative 1 will give me a minus 4. So 10 minus 4 will be 6 plus, and then we have plus 22i. Okay, this divided by 20 would be my answer. 6 plus 22i divided by 20. Now, if we went ahead and simplify this, which we should always simplify, we end up getting 3 over 10 plus 11 over 10i. Because this is in complex form. A plus bi. We also call this standard form of a complex number. You'll often hear that called by standard form of a complex number. Okay? All right.